Can you imagine that this single thing can cause production outage? No, nobody deployed any broken code or nobody dropped any production database, but it was actually a retry policy that caused a production outage. So let's discuss in this video. So imagine this is your architecture and you are using microservice architecture. So this is your service A and this is your service B. Client is communicating with service A and this service A is communicating with service B. Everything is very simple, and this service A, it sends around like 1000 requests per second. So service B can easily handle 1000 requests per second. And you have written the code for retry policy just like this. So if any request fails, then you will retry it up to 3 times. So everything looks fine. Service A sends around 1000 requests per second and service B is handling those requests. But the problem arises, suppose that due to some network hiccup or some another reason, this service B, it becomes a little bit slower and the response times increased due to some reasons and some of the APIs got failed. And to handle that, you have already retry policy in place, so that if request fails, then you will retry up to 3 times. So this looks harmless. Now the problem arises when suppose that few requests failed. Now as the number of requests failed that got piled up, the problem becomes worse, because earlier it was sending 1000 requests, right? But now that 1000 requests got failed due to some network hiccups. Now each of those 1000 requests, those requests will be retried 3 times. 1000 request is failed and each of the 1000 requests is retried up to 3 times. That means it became 4000 requests. So now service A is sending 4000 requests to service B instead of 1000 requests. And if out of those 4000 requests some got failed, then even those are also retried, and this way this number can grow really huge and this can take down the entire service B, because now due to the cascading effect, the service B is getting lots of traffic due to this retry policy. This scenario we call it as a retry storm. So we call this scenario as retry storm. So here due to some failed requests, the number of retries grow exponentially and it creates a huge amount of traffic to the services. So the question arises, are retries bad then and you shouldn't use retries? Well, not really. Let's see how you can mitigate this problem. So there is a concept called exponential backoff. So what we do is that, so instead of retrying blindly, like as soon as the request failed, we retried it immediately, we wait longer after every retry. So imagine that the first retry was made after 100 milliseconds and that got failed, and instead of making another retry after 100 milliseconds, what you do is that you wait a little bit more longer before you retry once again. So here you can see we are waiting for 200 milliseconds. Now even if that also fails, then we are waiting even more, 400 and then 800. So this way we are waiting longer after every retry, and we are kind of like, you can say, we are giving a breathing space to the service that is already struggling. So this service B, it is already struggling and we are giving it some more space to recover, more time to recover before we once again attempt a retry. So this thing is known as the exponential backup. So instead of retrying blindly, you wait longer after each retry. So we have this exponential backoff now. Now if you just think carefully, you would see that, imagine the scenario like suppose 1000 requests came, okay? So it got 1000 requests and we have exponential backoff. So 1000 requests got failed, and now due to the exponential backup, this 1000 requests, all of those requests are retried after 100 milliseconds. And suppose that those also failed, now these are again retried at 200 milliseconds. So you are seeing that even if we are using the exponential backoff, we are still retrying. The retrying is still happening at the same time. Like after 100 milliseconds, all the request comes, and the certain amount of time another set of requests comes. So you can see like we are again bombarding the server with lots of requests, because the request came at the same time and even the retries are also happening at the same time. So this can again overload the server. So exponential backoff also doesn't solve this problem entirely. So to solve this problem, we have another concept called jitter. So now we see that if we just only use the exponential backoff, even if we are waiting longer for each and every retry, but we are still making the retries at the same time. So what jitter does is that it randomizes the time after which you should be doing the retry. So if you just use the exponential backoff without jitter, then all the retries are happening at the same interval. But if you use the jitter, so you are randomizing the retry time. So you can see now the retries are not happening at the same time, like it is happening after random time. So this way server load gets distributed and server is not bombarded with another set of retries that is already struggling. So the service is already struggling, so we are not once again bombarding the server with the retry attempt at the same time. So we are randomizing the retry time so that the retry attempts are distributed and it doesn't come at the same time. So if you are adding retry policy, then these are the two things that you should definitely do: exponential backoff and this with jitter. But there is another thing that you can do that we are missing here. is to adding a maximum retry attempt. Another thing that we have done here is that you should always add maximum retry attempt. So you can see we have already added the retry attempt, maximum retry attempt here. So make sure you are also adding the maximum retry attempt, because if you don't add any maximum retry attempt, then because this service, this is already making lots of requests, so it will continue keep making requests, and even if all the requests are failing, this is still making lots of requests and retries. So this will make this service be even more overwhelmed. So make sure you are always adding a maximum retry policy, so that after certain amount of retry, you will give up and you will fail the request. Now another thing that is worth considering is that there is a concept called circuit breaker. So in microservices architecture, we usually have circuit breakers between different microservices. So what this circuit breaker will do is that, so as soon as it is saying this service B health is going down and service B is not healthy anymore, so it will open the circuit breaker. So open the circuit breaker means the request will not even retry. The request will not go to service B and it will fail it immediately, because the circuit breaker has already identified service B is down, service B is no more healthy. So there is no point in making further request to service B. It will just open the circuit breaker, and that means the request from service A to service B will not go anymore. So it will directly fail those requests. So the job of the circuit breaker is pretty much similar to the circuit breaker concept that we have in electrical engineering. So if any service is not responding, it is not healthy, it is down, then the circuit breaker gets open and no more request goes to this down service, so that the situation doesn't even become much worse, because there is no point in making further request because the service is already down. And once the circuit breaker checks that okay, now service B is up and running, then this circuit breaker will close. That means request will once again go from service A to service B. Takeaway from this video is that the exponential backoff, this gives the struggling system some time to recover. So it sees that the service is already struggling, so it doesn't attempt retry as soon as it sees the request has been failed. Instead, it starts to wait for longer time before it attempts any retry. And this jitter prevents everyone from retrying at the same time, because it randomizes the retry time to ensure that everyone doesn't retry at the same time. And the circuit breaker stops us from attacking already failing services. So yeah, circuit breaker is already checks like this services is already down, so it doesn't send any further request to that, so it will directly fail the request. So circuit breaker will basically open and it will no more send the request to that. And the retry limits remind us that reliability isn't about trying it forever, it's about knowing when to stop. Exactly, because if you don't have any retry limit, then it will keep on making requests, make the situation even worse. So you need to remember that reliability isn't making sure that every request succeeds. Reliability making sure that one failure doesn't take down everything else. Yes, exactly. So when you are adding retry policy to your application, make sure you consider this scenario, because if you don't consider these scenarios, then if any services goes down, then that can cause massive outage in your application. So I hope this video was useful. Let me know what you think on this one, and as always, thanks for watching.